looked up that problem that we were working on in a tutoring session from the guy's videos, and I made sense of it. So this is what he's explaining. So here you have tangent inverse of tangent 6 pi over 7. So remember what we talked about, when this is not on the unit circle, things get a little bit crazy. So we have to do kind of a little bit of extra work to think about things. So the first thing that you want to do is you want to find the restrictions for tangent inverse x. This is what they gave us. We know the restrictions are the domain is negative infinity to infinity. I know the y values, which is the range, are negative pi to pi over 2, negative pi over 2 to pi over 2. This is what we discussed, right? Like, how do we know, do we go this direction, or like, is it in these two or these two, right? So what I notice is this means, right, if we start at 0 on the unit circle, which is right here, right, we can only move up to pi over 2 going this way, all right, and down to negative pi over 2, like that. If we start from here, right, so that's where I was confused, I believe, because I said that it could go this way. This definitely proves it, because we always start from 0 on a unit circle and we go counterclockwise or clockwise, right? So remember, so this range, negative pi over 2 to pi over 2, for this problem in particular, this means if we start at 0, right, on the unit circle, we could only move up to pi over 2, right, going this way, and then down to negative pi over 2, all right? So now, the next thing we want to do is, so let's figure out where 6 pi over 7, just in general, without the tangent function, is on the unit circle, right? So if we look at the unit circle just a little bit, so if you look here, right, at the unit circle, we're looking for where is 6 pi over 7, right? So 6 pi over 7, you have on the circle here 2 pi over 3, 3 pi over 4, 5 pi over 6. So 6 pi over 7 will be somewhere like around here, if that kind of makes sense, right? We're not even worrying about right now about whether it's here in this direction here or whatever, right? We only care about where's 6 pi over 7 in general on the unit circle, right? So 6 pi over 7 is just short of pi. Okay, so the angle for 6 pi over 7 has to be slightly above pi on the unit circle. So how do we determine it's just above pi? Well, if we look here on the unit circle, here I have 2 pi over 3, 3 pi over 4, 5 pi over 6. It kind of would make sense that about 6 pi over 7 would be here. And then, why do I get pi right here? Because technically, right around here, you should have 7 pi over 7, where if 7 pi over 7, if those 7 simplify, you're left with just pi. So I could determine that that angle is most likely around here. Okay, so I kind of sketched it out here. So the angle, right, for 6 pi over 7, right, from the angle here, right, this is the terminal angle, the reference angle, right, or the terminal angle, this is the angle we're looking for. 6 pi over 7 has to be right around here, just under 7 pi over 7, or aka just pi, right? So that's where we get that, okay? Now, the next thing is I'm going to notice, right, that 6 pi over 7 is in quadrant 2, okay? So it's right here. Right, it's in this quadrant. It's in these guys right here. Okay, that's just where the angle is. No tangent, no nothing, right? It's just in the ass where the angle is. So we have to keep that in mind. Okay, now since 6 pi over 7 is in quadrant 2, that means the x value will be negative and the y value is positive. That kind of makes sense, because look at all the x values here. They're negative, and all the y values here are positive. This is going to be negative x comma y, like that for this. Whatever it is, I don't know. I just know it's negative x comma y, and I sketched it up here as well, right? You have negative x comma y for 6 pi over 7 right here. So now, right, let's go to step 5. Now we can worry about tangent. So tangent is defined as y over x, right? In general, right? Tangent is just y over x, or sine over cosine. We get a little bit more into it. Or more properly, tangent theta. So tangent of any angle is just y over x, or sine over cosine. Okay. Now in this particular problem, with our given info that we found, right, we can see, right, that for tangent theta, that's actually y over negative x. So this is saying aka tangent is going to be negative, right? So, right, so tangent is negative. That's what we're saying here, right? So whatever I plug in, I'm going to have to find a negative tangent reference angle, all right? So next step is, right, so we have to ask ourselves, where is tangent negative from negative pi over 2 to pi over 2, right? So I'm kind of stuck here. Remember, I'm stuck here going this way to this way. Where are my tangents negative? If you look here, these are all positive, right? And there's this little cool trick, or I think it's an anagram, or I don't know what it is, that where I could say A, S, T, C, right? Is I'll say all students take calculus. All trig functions are positive. Only sine here is positive. Only tangent here is positive. And only cosine here is positive. And they're reciprocals, meaning like sine and cosecant, right? And tangent and cotangent, and cosine and secant. All right, so this is important. So if this tells me where all of my trig functions are positive in the quadrants, it could also tell me where they're negative, right? So that means that this one, tangent, will be negative here. I'll just put a dot, right? And then it'll be negative here. And that's true because remember, we looked at 6 pi over 7 and it was negative in quadrant 2, okay, this quadrant. So it also has to be negative in quadrant 4. So this tells me, right, if we look here, like these will all have negative tangent values because tangent is defined as tangent equals y over x. And then as you can see, between here and here, these are all negative y values. So if I put in y over x, they'll all spit out negative values for tangent. All right. So then this lets me know that we have to find a reference angle in quadrant 4 now, okay, for this whole function. Right? So remember, we're working inside and out, okay? So now I know for this whole function, I'm stuck in quadrant 4. But given that I have 6 pi over 7, right, which is my original, that spit out in quadrant 2. So I'm going to find that reference angle in quadrant 4 to give me my answer, right? So to find that reference angle, I just look at my 6 pi over 7, right? And it goes here. And then I could find out, well, what is the angle opposite of that in quadrant 4, right, in Q4. So then I could just make a nice little sketch going this way, and that angle will be there. Now the question is, thinking about it, we could look at the unit circle, right? If I look here on my unit circle, that's a random value. Remember, the original value was not a value on the unit circle, so therefore I cannot end up with the value on the unit circle. So what value is this? I can't put this as my answer or this as my answer, right? So because it was a value that we thought of, right? So what I have to do is then say, well, what is the true reference angle, right? This is what we thought about earlier. The true reference angle is, this is 6 pi over 7, okay? So what I need to go from here to here, right, from here to here to get to pi is I have to do 6 pi over 7 plus 1 pi over 7, because that gives me the 7 pi over 7, or aka just pi, right, because these cancel. So then my true reference angle is this guy, but on this direction, right, in quadrant 4. So if it's in opposite, right, if we go and then we go here, he's going to turn out to be negative, right? So instead of 1 pi over 7, it's negative 1 pi over 7, right? And then you could tell it's negative because if the reference angle is here, we start here always going either this way or this way. I'm going down clockwise, so those angles have to be negative. So therefore, that's why the reference angle is negative pi over 7, right? Since we're rotating clockwise. And if we do some little bit of, arithmetic, this simplifies to negative 1 over 7 pi, which is our solution. Now, that's a lot of thinking, right? Which is good. I'm glad you kind of came to me with this problem because it helped me kind of refresh my memory on this, and also to kind of be like, oh, that's what it actually truly means, right? Because sometimes we forget. I don't know if you're into engineering, but a lot of the engineering stuff will be just calculated, right? But I like that you kind of like, well, let me think about it. Why is this happening, right? So now we know why this happens. What you could do, this is my favorite friend. This is a dusty old Casio FX991EX. I've had this for a long time, right? You could just get one of these, and these will do the calculations for you, right? But I like knowing the idea behind it. So that's how I ended up being a math major. I like the ideas behind things. But in general, as you could see, you could just punch this in the calculator and it gave us the solution that we thought of. All right. So my tip is, using this and the logic behind this, we could kind of find angles that are not, right? Like original angles like this one, like 6 pi over 7, right? That is not originally on the unit circle, that we kind of have to think about or do a little bit of, brain work to kind of figure out, oh, where does it go, right? Now I know it's, oh, look, well, this is about, like, to do it quickly, 6 pi over 7 is about here. To get to there, I need to add a pi over 7. So therefore, the reference angle is this guy, right? And then I know I'm stuck here, right? Because tangent has to be negative, right? Because all these guys are negative here, represented here. So if I divide them over whatever, I get negative, right? Or all students take calculus, right? So if this is 1 pi over 7, well, then this guy from here to here, right? This guy from here to here has to be negative 1 pi, right? This has to be negative 1 pi over 7.